Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and we are getting to one of my favorite sections of work in the whole grade 11 and 12 syllabus, trigonometry. Now, when we look at trigonometry, specifically this that I'm going to do today, none of these two questions actually require you to do any metric trigonometry. So before we get into the meaty part of analyzing it and going through all of this, try this yourself. Hit the pause button and try it yourself. See whether you can do it. Can you simplify? Can you prove it? And then we take it further from there. When we look at questions like these, I'm telling you guys now very clearly, there's so many score marks, but I see it year in and year out. My students don't know the basics. They struggle with when are things positive, when are things negative. So I encourage you to go and look at the other videos as well. If you are struggling with trigonometry, look at my other videos where I go through the theory in so much detail. But for this, I'm going to start by analyzing this question. So it says here, without using a calculator. Now, I'm not actually going to worry about that at the moment, but what I want to focus on is there's always two steps. Ladies and gents, always two steps. If you get these two steps right, you usually have 30 to 40, even 50% of the marks you already have. Okay? The first step is get your angles between 0 degrees and 360. How do I do that? I've got two options. Number one, I could either add or subtract 360 as many times as I want to. Or I can look at the angle as if it is in the fourth quadrant. Okay? Why fourth quadrant? Because it changes the direction of measuring the angle. So like tan negative x, it's easy to look at it as if it is in the fourth quadrant. But I'm getting ahead of myself. So once the angles are between 0 and 360, then I look at getting the angles between 0 and 90. How do I do that? By using the cast diagram. But not co-functions, ladies and gentlemen, just the normal cast functions, okay? My students get too, I want to say they overthink trigonometry. So I'm going to tell you, just do these first two steps proper, and the rest will fall into place. But now let's look at the actual question without using a calculator. That tells me, first of all, I've got special angles to look for. Secondly, if there aren't special angles, I've got to get the angles the same. And a lot of times things are just going to divide away. For this, we usually look for co-functions. So your 90 degrees. 40 and 50, 20 and 70, 10 and 80. Okay, those kind of angles. If that doesn't work, draw a triangle from the information. If this doesn't work, I always have identities in my back pocket. Now, which identities am I talking about? I'm talking about grade 11 identities. So tan x is sin x over cos x, but also that cos squared x is sin squared x, cos squared x plus sin squared x is equal to 1. And of course, I can get cos squared alone by saying it's 1 minus sin squared, or I can get sin squared alone, 1 minus cos squared. But now in metric, there's also this next layer that comes on top of it, which are, okay, compound and double angle identities. So if you're in grade 11 and you're looking at this, you wouldn't know what I'm talking about. But that's next year's worries. And in these two sums, we are actually not going to look at compound and double identities in detail, although I am going to talk about them. So if you are a grade 11 learner and you're looking at this and you don't know why I'm doing what I'm doing, it's because I'm looking at compound and double angle identities. Let's get into the first two steps. First of all, I look at getting my angles between 0 and 360. So tan of negative x is in quadrant 4. Tan is negative there, so I make it negative tan x. Secondly, I now want to get my angles between 0 and 90. So the sine of 140, okay, let's start with a 360 minus x. That's an easy one because that's in fourth quadrant. So sin is negative there, so I'm sitting with negative sin x. The same with the sin 140 is 180 minus 40, which is second quadrant, where sin is positive. So that's why it's positive sin 50. The cos 50 is already fine. That's 100%. Now I'm going to go and I'm going to feel like Alice in Wonderland, because some of you already see where the sum is going. But I want you to just, mentally hit the pause button. Not physically, but mentally. Look at what I'm going to do. If I look at the 40 degrees, the sine of 40, I want you to open your mind and think about all the possibilities you should be looking at. First of all, cofunctions, the 50 degrees, because 40 and 50 together gives me 90. So sin can change into cos. But also, I could look at 2 times 20 because it's a double angle. Again, grade 11s, you won't know what I'm talking about, but it's just good to start thinking about it for next year. But I could look at compound and compound angles. When I look at compound angles, I can look at 30 plus 10. Why specifically 30? Well, it's a special angle. Same with 45. I can go 45 minus 5. Or I could look at 60 minus 20, depending on the situation. That is important. Okay, I'm just trying to get you to open your mind at all the possibilities. But in this case, I'm going to look at 50. Why? Because of the bottom cos 50. Because that is cos 50, I'm going to look at it. If the rest of your sum had 20s in them, I would have looked at 2 times 20, for instance. Or if there were 10s, I would have looked at 30 and 10. If there were 5s, I would have looked at 45 and 5. Just understand what I'm doing. It's just alerting you to all the possibilities. So sine of 40 is going to change into cos of 50. I'm going to keep the sine x the same, and I'm going to keep the cos 50 the same. But now, I want to change the tan x. So I'm going to change the tan x into sin x over cos x. Okay? I'm just leaving that negative in the front. Okay? Leave it there. Don't worry about it. We'll get back to it later on. The beautiful thing is the cos 50s divide away, leaving me with negative sin x divided by negative sin over cos. I love to write it like that. Sorry for leaving out the x's. Negative sin x over cos x. Let me talk right. Because if I speak right, if I talk maths right, I'm going to write it down correctly. Okay? Changing the divide into a times, I reciprocate. So I tip and times, like some of my students use, or KFC. Keep the front one the same, flip the back one, change the divide into a times. KFC. I love all these Interesting little acronyms. But I'm changing the divide into a times. I'm reciprocating, which means the sins are going to divide away, and I'm left with the cos x. So the sin x and that sin x divide away, leaving me with a final answer of positive cos x. Look at the original question. Simplify into an expression that has one trigonometric ratio. Does this answer the question? Yes. So I'm going to move on to the next question. Boom. Question 5.2. Prove the identity. Again, even with proving the identities, I'm always going to follow my first two steps. Get my angles between 0 and 360. Get my angles between 0 and 90. So once I've got my angles between 0 and 360, which I don't have, I'm going to, before I actually do that, I'm just copying the rest of the sum over. What am I going to do with that 540? I'm going to subtract 360 in this case, leaving me with cos of 180 minus x. Still, my angles are not between 0 and 90. So I need to handle that. That is in quadrant 2, which means, again, just copying the rest of the question over, that cos of 180 minus x is negative cos x. So I now, at this moment, start becoming obsessed about where am I wanting to go. Once my angles are between 0 and 90, I know I've got to focus where I want to go. I want to get just cos x in my answer. So the 1 plus cos x in the denominator is fine. The cos x plus 1 at the top is fine. But the sin is not fine. That sin x is not fine. So I'm going to try and change the sin squared x into something that has causes in them. How can I do that? Well, I can use grade 11 mathematics by making it 1 minus cos squared x. Again, I'm not just doing it on a whim. I'm not just doing it because it makes me feel good. I'm doing it because I only want cos x in my answer. If I now multiply out, so I'm simplifying my numerator, I'm going to further just add and subtract the like terms. What do you see at the top? At the top, there is a trinomial. A trinomial that you can actually factorize into 2 cos x times by cos x, negative 1 times by plus 1, and this is going to be all over 1 plus cos x. Now, I know from a lot of experience working with grade 11s and 12s, my students struggle with this factorization. So what do? I advise my students to roughly on a piece of paper or next to the question paper, next to the sum on the question paper, in pencil, make cos x equal to a, for instance. And then I'm sitting with 2a squared plus a minus 1. Now that my students go, oh, sir, that's like easy to factorize. I just 2a minus 1 and a plus 1. Yes, great. But sir, that's exactly that numerator. Now there are many ways that you can also kind of go and say, how can I manipulate this? Well, I know that I want my cos x plus 1s to cancel out. So I know one of the brackets are going to be cos x plus 1. Okay? So there's some ways you can try and think about it, but what I love to just do is use the K method. That way you let cos x equal to A or to K, and then factorize, divide away, and my left-hand side is equal to my right-hand side. Oh my goodness, is maths this easy? Can it be this simple? Yes, it can, but it starts with the first two steps. Get my angles between 0 and 360. Get my angles between 0 and 90. And then manipulate the living daylights out of the sum. Ladies and gents, please make sure you get this right. Have a beautiful rest of your day. And please tune in for the next video where we are going to do question 5.3 of this exam. I wanted to keep it separately because that's where we're bringing in some grade 12 beautiful trigonometry. So this is Mr. VG signing out. Keep well, keep safe. Cheers.